Hello everyone. Today I will show step-by-step guide how to install EthoGrid ToxMate. So let me introduce myself. My name is Mahmoud Yusuf and I am PhD candidate at Chung-Der Christian University, and I am pursuing my PhD in biomedical engineering. So let's start. So this project is supervised by Professor Chung-Der. So he is the distinguished professor, and we have also collaboration for this APP development. Uh, we have a collaborator, Gilbert Odera. He's a postdoc candidate at CYCU, and also Peter Siriger and Kevin De Corina for collaboration. So we developed EthoGrid ToxMate for the circadian rhythm study for the platyfish to see a uh, chemical induced disruption study on the day and light dark cycle to see the circadian rhythm. So we use the ToxMate device, which can record 24 hours continuous videos. So we have a very big data set. So for a such big data set, so we developed the EthoGrid ToxMate, which is very high speed behavior analysis tool for processing large volume videos. So in we will go step by step how we can install this app. So this installation will be totally dependent on how the system is configured, what kind of operating system you are using. Suppose you have a Linux, different version, Mint, Ubuntu, Fedora. So they're totally dependent on your system. So you will run these commands on your terminal. So you will install Git LFS, and for Windows user, you will also need Git software to clone this repository. You will run this command git clone. In the first step, to pull this repository, clone this repository on your local system. Then you will change directory cd space ethogrid toxmate slash app, and then you will run this lfs command to pull some AI models, YOLO models on your system, and you will run Python install app.py, this script, which is inside this source code. So let's give you the idea of our source code. So there are two repositories, APP and benchmarking models. So we developed the benchmarking models, this pipeline to find out the best algorithm for our study, which should be high performant and most precise. So we did tested six different deep learning architectures: faster RCNN, SSD, and YOLO. So faster RCNN is a two-stage detector. SSD and the YOLO are the one-stage detectors. So on the basis of our benchmarking final benchmarks, we find out the optimal model YOLO V11 in our case study. So this is our benchmarking model. So we find our best model from the benchmarking model pipelines. And after that, we have this app. You will install using this script, install app.py. If you find any issue, then you can also install from the requirement.txt. So you can install these modules. Once you install this install app.py, you will see v.vnv virtual environment. So you will activate this environment using the command source v.env in activate. So this environment will be activated. So you will see it here. And also for running the app, so you must have NVIDIA graphic drivers. So when you run this command, NVIDIA -SMI, so you must see the output. If you found some error, you need to set up to GPU driver for your system. So when you got a success, then you can use this tool for high performance. And after this, you can run your app python main.py. Make sure you are inside the directory ethogrid toxmate slash app. When you run this, so ethogrid toxmate app will pop up. So this is the splash screen, and this is the ethogrid toxmate GUI. So we have different button for each part. So you can use the frame extractor for to load some of your raw videos, to extract some frames for training your YOLO model. So maybe you train the YOLO model separately for this app. So you will just can use this frame extractor utility and also video splitter. So if you have a circadian rhythm study, so you can use this part to split your videos. Suppose you have 1000 videos, you want to split each video in different chunks. So you can load the raw videos from these input options, and also the output uh, uh, folder you will provide where the chunks will be saved. You can also chunk duration, let's say it's 24-hour video, so you can chunk it. The chunk duration can be a 60 minutes, can be dependent on your experiment. So this is video later. So run detection pipeline. So this is the important one. So you will load the raw videos here. So we have the demo files I have provide in the GitHub. So you will, for just testing, just load this video, and I also provided best.pt file. Also, let's say output directory is same, and let's run it. And you can also make the confidence threshold to 0.4 to 0.99, maybe 1 you need, what kind of confidence threshold you need. Still, we got 54 FPS even after saving the video and save the detection. If you turned it off, if you don't need annotated video, so you may get, if there is no IO operations, you may get more than 200 FPS for the YOLO models. So let's see the results now. So this is the inference we got for the YOLO. You are seeing it's a very good detection result. So our next step, so we also got some detection file. So this will be needed in our next step. So our next step will be to draw the grid on our, you can say, the video. So we have a 4 columns, we have a 4 rows. So you can also select scale the X, different scales. Also same for Y, like this one. So I have already saved my setting. So let's load it. Once you set it up, the perfect arena for, let's say these are the 16 tanks. So there will be 16 grids. So maybe in the study you want, let's say 2 columns and only 2 columns and 1 row. So you can just input the number of columns and rows. So all detection data. So just load the detection from the load button. So you are seeing now. So all detection is classified into number of tank wise. You can say the it's assigned like 1, 2, 3 to 16 to each animal. So if you have 2 arenas, so maybe you can input the columns and rows accordingly and save the grid JSON. And you can also output this export video and also Excel file, and also can export some tank wise locomotion data and also centroid CSVs. And this step is necessary if you have very big data, like thousands of videos. So you just save the settings from here. So these settings will be saved. This will be needed in the batch processing. So let's click on the batch process. So you will load your raw videos from here. Just click on the raw video we have, setting.json. And the CSV file for detection, we got the same demo files, and also we will output there. So there are options you can select. So number of animals per tank you have, we have 1 animal now. So if you don't need this timeline legends, these are for T1 to T16. This T1 is the tracking data for the T1 tank fish, and similarly for the 16. If you don't need the overlays legend timeline, this is the legend fish. So if you don't need that, so you can turn it off from here. And these are the different formats. We will currently output the Excel heat maps. and also trajectory for this video. So let's see the results now. So, so in this way, you can process on a single click thousand thousand videos, more than 1,000 videos if you have. So if you see the heat maps, so these are the trajectories from this single image. You can see which animal's locomotion is, which one is more active. So if you see here, so this animal is not active. So just by seeing the trajectories, you can find it out. And also uh, heat map we have in output. So that's totally depend on your experiment. And if you see the annotated video, so tank number, so this is the tracking. So by default, the tank number is assigned to each animal. So currently, as we have one animal, so we have no trackers now. In the future, we will try to integrate MOT, multi-object tracking, maybe bite sort, strong sort, integrated for the multiple animals. So this is all about today installation guide and also the usage guide of EthoGrid app. So thank you so much for the watching. Goodbye.